In this video we're going to look at how we can use tree diagrams to solve probability questions. So here we're told that there's a bag that contains 6 blue counters and 4 red counters, and that David removes a counter followed by John. And we're going to find various probabilities. So first of all I'm going to show this information on a tree diagram. So my first set of branches are going to indicate what happens when David removes a counter, because he's removing one first. So you can either get a red counter or you can get a blue counter. And initially there are 6 blue and 4 red, so the probability he picks a red is 4 out of 10, and the probability that he picks a blue must therefore be 6 out of 10. So then I'm going to consider my second set of branches, which is going to represent John. And again, he can get red or blue. And I need a double set of branches here because I'm looking at, well, John can get a red or a blue if David picks red, and he can also get a red or a blue if David picks blue. So the probabilities this time, well, one red counter has already been removed by David in this case, so there's only 3 red left out of 9 in total. But all 6 blue are still there, so that's 6 out of 9. Whereas if David picked a blue the first time, all 4 reds remain, but there's only 5 blues. So that's my completed tree diagram. And now I can use this to work out the actual question. So the first question says find the probability that both counters are blue. So David gets a blue and then John gets a blue, and I'm going to multiply the probabilities here. So I've got 6/10 multiplied by 5/9, so that gives me 30/90, which is a third. Second one then, so one is red and one is blue, so it doesn't specify whose is red and whose is blue. So if David's is red, then John's can be blue, or if David's is blue, John's can be red. So what I'm looking at here is David's red followed by John's blue added to the probability of David's blue and John's red. So in this case I have a combined probability of 48/90, and I can simplify this down to, so it's going to be 7/15. So next one, David's is red given that John's is blue. So we know John's is blue, so we know that this branch and this branch didn't happen. Okay, we know it's John's blue. So what I want to work out, I'm just going to use a little bit more space for this question, so I'm going to work out that David's is red given John's is blue. Well, the chance that David's is red and John's is blue is 4/10 multiplied by 6/9. So it's going to be that out of the probability that John's is blue, because that's the new total really. So we've got 4/10 times 6/9 added to 6/10 times 5/9, and that will simplify to 24/54, which is then going to simplify again, and that's going to simplify to 4/9. So I've got one more question to look at here, and this was looking at that David's is red given John's is red. So a similar kind of idea here. So the fact that David's is red would be 4/10 times 3/9, so that's David's is red and John's is red, over the total probability that John's is red, so that's 4/10 times 3/9 added to 6/10 times 4/9, which, so that's that branch and that branch. I'm ignoring the blue branch and the red-blue branch because we know they can't have happened. So now I can simplify this down, so that simplifies down to 12 out of 36, so that is 1/3.